Alright, hello, welcome on today's class, and today we're gonna talk about simple audio processing. So we're gonna record the audio from the microphone. Possibly we're gonna also play it out later on. Not using Android, you can use any application that supports WAV files. So yeah, we're gonna use a WAV file. So the main goal of this class is to record audio into the device, save it as a file. We're gonna save it as a file specific for the application. So this will be not a file that can be accessed by other applications on the device, but that is only a slight change. So I'm gonna show you a very similar path. Right. So we start with our main activity, and in this main activity we're gonna start by creating 3 buttons so that we can start well, actually 1 button and 2 text views so that we can start recording and get some status information. So we're just gonna create them here, and let's just adjust those things here. Let's make this one in the middle. Adjust these two to the yeah, and the last one, this one, we're gonna also adjust it to the middle. Okay, so now we're gonna call these text views. This one will be current action, so that when we're recording, we know that we're recording, and when we're not, we know that we're not. And this one will be last result, so if we manage to successfully record or not. And this one is gonna be record button. Okay, so we have these 3 widgets, and that's great. So now what we're gonna do is we're gonna we're gonna do one more thing. So here we're gonna also add to the button, we're gonna add an on-click callback, and we're gonna call it toggle recording. So toggle recording does not exist in our activity, so we're gonna create it. And if we're toggling here, so we're gonna keep some, we need to keep some states, whether we are recording right now or not. So I'm gonna just do it with a boolean. Currently recording, and we start by not recording, so that's fine. So now if we're currently recording, we're gonna stop recording, and else we're gonna start recording. That's I guess pretty self-explanatory. So let's create those functions: stop recording and public void start recording. And we're gonna toggle it, and I'm actually gonna do it this way. So I'm gonna negate it here, and I'm gonna negate this condition. So if I change to not recording, then the stop recording and start recording will be executed with the right state. So the state changes first, and only then I change the logic. It's not how you would do it in a real life application. So in a real life application, you'd rather do that somewhere in the end of the stop recording and in the end of start recording. So you would rather do it here. But I'm gonna do it in the beginning because of some other dependencies that I'm gonna introduce in a second. Okay. So our stop recording and start recording. So first of all, what we're gonna do is we're gonna adjust the texts. So stop recording will set text view, which would be find view by ID or ID current state, current action, and we're gonna set text to not recording, and we're gonna set this one to recording. So that right now, so we're able to check if our application interacts correctly with the other ones. Okay, so this was the previous version, and right now we're gonna run a new one. So let's give it a second, or maybe two. So invocation finished, starts. Okay, so recording, not recording, yeah. And we also have this button, and I'm also gonna change its name, and I'm gonna call it well, it's a button, and its ID is this record button. And when we start recording, I'm gonna set it to record, and on start I'm gonna set it to stop. All right, so that was the fun part. So now let's go to the important things. So right now we need to start recording, and we can start recording. Well, first of all, what we need to do is a record. So we need to create an audio record R. Let's call it R, which is a new audio record. And this record takes an audio source as an argument, and this audio source is, in our case, mic. Sampling rate, I'm gonna use standard sampling rate, and this is because this is the only one that is supported by every device. Sample rate, yeah, and you can read it here. So the sample rate in hertz is the sample rate expressed in hertz, pretty obviously. And this 44100 is the only rate that is guaranteed to work on all devices. Others may work or may not work, and we're not gonna guess here. So we're just gonna use this one. And then we have a channel config, which we're gonna use mono channel. Audio record, I guess that's yeah, let's check it out. Where is this one taken from? Audio format. So yeah, my bad. So this is audio format. We're gonna use a channel in mono, and then the other one is buffer size in bytes. So we're gonna say our buffer is 16 kilobytes. Oh, and here we have also audio format. Oh, and encoding, yeah. So we're gonna use PCM encoding, and let's say this will be an 8-bit encoding. It doesn't really matter if we use 8-bit or 16-bit here. For the quality, it does matter. So 8-bit is so 8-bit sound is pretty distorted, so it won't be very clean. Obviously, it's twice smaller. But for our case, it won't matter much. I mean, we could use 16-bit too. This would introduce a slight problem if we want to process it, so that we will need to make sure that our data is little endian in the end, because WAV files are little endian, and for example IF files are big endian, so you need to make sure which endianness you use. We're gonna use 8-bit because we don't care about audio details right now. Okay, so now we have two options. So we can set a listener, which we did previously, or we could start it and then read bytes manually when we are ready to read bytes. Now this makes sense because we didn't do it previously, so we didn't use this version, this option for sensors. So I'm gonna show you how to use this polling well, not like, it's polling mechanism. Now it does introduce one problem from our perspective. So once we read, read is a blocking operation right now. So that's a buffer, and we create a new byte. And let be 16 kilobytes, 24. So we want to read this buffer. And there is, I think, something more here. Yeah, an offset and size. So what we want to say is we start from the beginning of the buffer and we read the entire buffer. And now the result is how many bytes did we manage to read. And if this is less than 0, it means that we got some error. And else everything's fine. Now you might see that we got a little problem here. So we read 16 bytes and that's pretty awesome, but at the same time we block our main thread, so we cannot really do anything else than reading. And that's not what we would like to have, because this will block our application and make it unusable and unresponsive, which is absolutely not what we want. Especially that we wouldn't be able to set this current recording to false. So what we're gonna do is we're gonna create a new thread that would read the data. And this thread is here. So we need to have some logic here. And actually we don't need this record out of the thread, so we can put it here. So now we read it, and after we read the data, we need to somehow transfer it to another thread, which would save it to the disk. Now, one important thing is that when you're spawning threads, you shouldn't be just throwing them around. So they need to be somehow managed. So what we need to do is we need to create a thread, a first thread for reader. That would be null, and a second thread for writer. Let's say let's call it disk storage writer, and this one let's call it audio reader. So just so that we know what happens. So we assign this thread, and then we start this thread, and once we stop, we need to join it. And the same thing for storage writer, we also need to join it. Now this thing is can throw an interrupted exception, because join is a blocking operation and can take quite a long time and might be interrupted by external interrupt. For example, if the application gets a signal or something like that. So in this case, yeah, we will block and some different thing will happen. So this join will be interrupted and we don't really know what will happen. So this is a very bad case, but might happen. So Java requires us to support it. Right. So we've created our audio reader. Now we need to have our storage writer, which would also be a new thread. And our new thread needs to receive data somehow. Now this data can be received by a queue. So we can get a blocking queue. Blocking queue. Well, let's say it linked blocking queue. That would transfer bytes byte arrays. And we're gonna call it, well, Q is probably a good name. And I'm not gonna give it any specific capacity. We could give it capacity so that it would block earlier, but we're not gonna do that. So we're gonna just allow the reader to read as many bytes, as many arrays as it needs. So what will happen is we're gonna take from Q here, and now this is also a blocking operation, so it can throw an interrupt exception, so it can be interrupted. Now this take returns a byte array, so this thing, and we're gonna assign it here. Now what we're gonna do is we're gonna write here. We're gonna do a Q, right? I think it is put buffer. And now we're gonna do that not once, so we're not gonna just read the first 16 kilobytes, but we're gonna do that as long as recording is enabled. As long as recording is enabled, we're gonna do that. And of course we're also gonna start the storage writer. Now, that said, currently recording is a boolean, and booleans are not the best way to interact between threads, because they may be cached on various levels, and they are not necessarily reread from the memory each time we need it, because by default that's a single thread thing. So if we want something that will be reread, we need an atomic boolean, which is of course a new atomic boolean and false. So the difference is that this is something that is guaranteed to be shared between threads at some point. So what we're gonna say is here we're gonna set it to currently recording to the negation of what it is right now. As it's easy enough for us right now, and here we're gonna say get, and here we also say get. And now what happens is that one of the threads reads data, and once the recording is stopped, it just exits, and the other thread reads this data and doesn't really do anything with it. Now we want to save this data to a file, and to save it to a file we really need to create this file. So what we're gonna do is we're gonna start with opening the file, opening a new file that would be that wouldn't be shared between threads. Now to do that, and here we of course also need a loop. So we're gonna do that while currently recording. So as long as we're recording, we're gonna do that buffer. Now what we're gonna do is we're gonna create a directory, a file. Do you know what? We're not gonna do it here. We're gonna do it later, because to write a WAV file we need to have all the file, we need to know the length of the file, and right now we don't know the length of the file, so we cannot just save it as a stream. What we could do is we could save it to somewhere on the disk, and then append the header. And this is something we could do. We're gonna just cache it in memory. That would be good enough for us right now. So we're gonna say byte array of arrays. So we're gonna say let's call it a mega buffer. New byte array of bytes that would or you know what, we're not gonna make it a mega buffer, we're gonna make it an array, a list maybe, or an array, how's it called? it's not an array. Array list. Yeah, that's how it's called. Array list of bytes, and this will be the whole content, and that's of course a new array list. So we're not gonna have this here. We're just gonna say content add qtake. Now there might be a little problem with that thing. Yeah, it's not correct. We're gonna do it in a second. So let's consider the situation where we're recording. We stop the recording, and when we stop the recording, the buffer is empty for some reason. I mean, it can be empty. We can be here. I mean, we can be somewhere else. We can just have put the thing to queue. So the buffer is empty, and writer is still waiting for that thing to happen. Now, if writer is still waiting, that basically means that it will never get the data, because the queue, nothing will write to the queue anymore. So what happens right now is that well, we need to put an additional item to the queue that would make sure that whatever happens, that whatever happens, the writer will finish, so it will exit even if there were no elements in the end. So we're just putting one last byte empty to the queue, so it reads everything, and then we need to do something, more or less, and that's more or less what we want to do. So first of all, we need to find a directory. And that's files directory. And here, after we do that, we need to create a new file in this directory, which would be something like files create file, directory to path, resolve, and we're gonna call it recording wave. And now create file can throw an IO exception, pretty obviously, but it returns a path, and that's what's important for us. So we get this path from here, and after we've got the path, we need an output stream. And this output stream will be a new file output stream. A new file output stream, and of course it can also throw an IO exception. And really we could just do it in a single way, single one. We could really just have done it this way. Yes, we have our stack trace, and this our output stream. So when we want to write our code, now what we need to do is we need to write. But before we write the content, because the content is what we want to end it with, we need to first write a wave header. And now what we need to do is we need to write the data to our file. But to write the data, we first need to write the header. Now the header is for a WAV file is pretty complicated. I mean, it has quite a specific format, and I've just saved it somewhere else so that I don't have to repeat it each time. every time I have to write something. So I'm just gonna write header, and I have a specification here. It's an output text, an output stream, and content. Our output stream is OS, and content is content, obviously. Now I'm just gonna copy the whole header into this function, and shortly discuss it. So we start with this ref string. Then we add the total length of the file, which is the length of the data plus 36 bytes of header. Now we do remove these 8 bytes for some reason. I'm actually not sure why this is done this way in this format. Then we have some wave FMT, and then there's a lot of things, and this thing is, I believe, 8. Or wait, maybe it's 16. Let me verify that. Length of data format. No, so that should be, I think, 16. And then we have several other things like type of the format. So this is PCM. So we have 1. Number of channels, we have 1. So here's 1. And this is all in little endian 16-bit numbers. So that's why we have two bytes for that. Then we have our sampling, and then is byte rate, and byte rate is calculated. Well, in our case is the same, but basically that's sample rate times bits per sample, which is in our case 8, times channels, which is in our case 1, divided by 8, which means that in our case it's basically the same as sample rate. And then we have bits per sample times channels, so divided by 8, so bytes per sample. And then we have bits per sample, and then we have data and data length, and then we can finally write the data. And to write the data, we're gonna do a simple loop. So we're gonna say for byte b in content, we wanna do os write b, and that's of course for all language. So and that's almost it. Now, once we run that, we're gonna see that we did run into some trouble. So we start that, and our app crashes. So the reason for that is that yeah, we got join on null. This time the reason for that is because we have the wrong logic here, because we want to stop recording once it's finished and not once it's done. I mean once it's done and not when we started. Right, so let's try again. And here we have recording, but the app crashes again. And it says that we've called start recording on an uninitialized audio record. Now the problem here is that we don't have the right permissions. And what we need to do is we need to say uses permission record audio. And now once we did ask for that, we need to actually ask for that permission. So we need to get it from somewhere. So we can ask the user to go to the menu and add right permissions for us, or we can use the same method we used previously in the previous exercise. So we can ask for the permission. So we can ask for permission, and our permission would be manifest permission record audio. And if it's not package manager granted, then we wanna ask for the permission. this new string, and this new string is manifest permission record audio, and request code is 0. So let's try it now. Let's try it now. Yeah, so we have our question if we want to allow it to record. So we want to allow it. Let's start. Then we want to say a few words so that they are recorded, and stop. And I have a file already exists exception, and that's because I was testing that earlier if it works correctly. So we want to remove that file, and that's actually pretty good because I can show you where to find those files. So data user 0, we got a path on our device, but the problem is that we need to get to the device somehow. And in Android Studio we can do that using Device File Explorer. It's here, or if you don't have it here, I think you can enable it here somewhere, maybe in Tools. Let me check that. And Tool Windows, or somewhere else. Yeah, anyway, you can find it. It's part of an Android Studio, and it's called Device File Explorer, so you'll find it easily on Google. Right, so we have this recording which is here. I'm gonna remove it because I'm gonna record a new one. Now, one more thing that is important is that you, on the emulator, you will actually wanna record something, and you don't have a microphone enabled by default. So to enable microphone, you wanna set this thing. Use host audio input, and this thing is whether. So you wanna set that you do use host audio input. And then you can record, say a few words to the mic if you want, and stop. And everything should be fine. Now we can synchronize that. And as you can see, there is a recording here. Then we can open it. Well, I would have to open it as binary. So let me check if I'm able to do that. Yeah, so VS Code is one of the applications that can do that. It has an extension called Hex, and using it you can open things in hexadecimal, which is pretty handy in those cases. Then I'm gonna save it to the default location. I already have it, but it doesn't matter. So the size is something like 200 kilobytes, not that much. And then I'm gonna reopen it, because I'll already have, well, maybe I can close it and open again. So I'm gonna just drop it here. I wanna open it using Hex Editor, and then you can analyze byte by byte. So we have the ref, then we have some size. We can see the details here. It's little endian, so you can change endianness here, but we will use little endian because that's the one that is important for us. And then you can see that the data does differ somehow. It's not a big difference, so this voice is pretty distorted, but there is something that you can listen to, and you can actually run that and hear it. I cannot do it now because the mic won't handle it well, but you can do it at home and try it out. And that's what this exercise is about. Thank you for listening, and have a great day.